Hello and welcome. We're going to continue in Chapter 7 today, and we're going to continue Section 7.5 looking at systems of inequalities. And today we're going to look at graphing systems that are using mathematical models. So here's what I mean by that. This is basically word problems. Help! Mr. Cody. This morning, Mr. Cody's wife gave him a $10 bill and instructions to pick up $5 to $10 worth of grapes and or cherries on the way home today. This was, back in a simpler time. Now, grapes are $2 per pound and cherries are $3 per pound. So, what can Mr. Cody get? Let's think of a few combinations that'll work here. One option, if I've got $10 to spend, is I could get 5 pounds of grapes and then no cherries, and that would be exactly $10. Or I could get something like, I could get 4 pounds of grapes, that's $8, and none of those, so I'm spending between $5 and $10. Or I could get, 3 pounds of grapes and none of those, and that's $6. Or I could get 3 pounds of grapes and 1 pound of cherries. That would be $6 and $3 more for a total of $9. Or I could get 2 pounds of cherries and 2 pounds of grapes. That would be $6 and $4 and spend all $10. Or I could get 1 pound of grapes, that's $2, plus 2 pounds of cherries, that's $6 and spend $7. Or I could get, so you can see there's a whole lot of combinations that I could get, and I could even do decimals because you buy the fruit by the pound, so I could get like 1.5 pounds of grapes, and that's $3 plus $6 more and spend 9 of my $10. So you can see there's actually like an infinite number of options I've got here. So what we're going to do is we're going to look at how to give an answer to this that actually shows every possible combination. And the way we do that is with inequalities. You can't really list every possibility. So what we do is we draw a picture of every possibility, and that picture is called a graph. Hey. So here's how we do that. What we're going to do is we're going to define variables. So my two variables are how many grapes am I buying and how many cherries am I buying. So I'm going to define x as the number of pounds of grapes, and y is going to be the pounds of cherries. And now basically what this means is however many pounds of grapes I buy, I multiply that by 2. However many pounds of cherries I buy, I multiply that by 3. When I add those together, I'll get the total amount of dollars, and my instructions are I need to spend between $5 and $10. So basically, if I do 2x plus 3y, that's got to be less than or equal to 10 because I can't spend more than $10. But also, if I do 2x plus 3y, that has to be at least 5. So 2x plus 3y is greater than or equal to 5. And those are the two, constraints here offered in the problem. However, there are some more equations I actually need to write. And these are basically real-world constraints on these numbers. One thing you have to consider anytime you're doing a real-world problem is, can these numbers be negative? Can I buy a negative amount of grapes? And the answer would be no, I cannot. That would be like bringing grapes back to the store and just setting them down and getting paid. And that's not how grocery stores work. So I need to say that x has to be greater than or equal to 0, and I need to say that y has to be greater than or equal to 0. Then what I need to do is I need to take these 4 inequalities and graph them all on the same grid. Now, one thing you'll notice is if you try to do shading for all of these, you will have to shade 4 different regions and then find the overlap of all 4 of those shadings, which can be very confusing. So instead of doing shading for each of these individually, let me show you what I'm going to do. I'm going to start by just graphing each of these 4 lines. So the way I graph these lines is by finding their x and y intercepts. So this one has an x-intercept of 5, because if you plug in a 0 there, you just do 10 divided by 2, and that's 5. And then a y-intercept, plug in a 0 there, 10 divided by 3 is 3 1/3, which is about right there. Then draw a line through them. It's a solid line because I've got an or equals here. And then I do the same thing here. I find the x-intercept by plugging in a 0 for y. 5 divided by 2 is 2.5. And then the y-intercept would be 5/3 or 1 2/3, which is about right there. And then I draw a line, again, solid line through those. And then you can see here, maybe you can see this, I do have lines also graphed at y equals 0 and x equals 0. So there's y equals 0 there, there's x equals 0 there, which are right on top of my x and y axis. But now what I need to do is I need to decide which side of all 4 of these lines should I be shading. So what I do is I look at this line right here, and I can test the point 0, 0, and I'll get 0 is less than or equal to 10, which it is, which means I need to shade everything below this line. But I'm not going to actually shade all of that. I'm just going to draw a little arrow here reminding me I need to be on that side of that line. Then I do the same thing here with this line. I plug in any point that I want. I'll plug in 0, 0. I get 0 is greater than or equal to 5, which it's not. So I'm not going to shade on this side of the line. I'm going to shade on this side of the line, which means I would shade everything above that line. But again, instead of drawing it in, I'm just going to draw a little arrow to show me I want to be on that side of the line, which means right now I would be in, this region right here. But because of these additional constraints, like this is not a reasonable number. That would mean I'd need to do like -2 pounds of grapes, and then I could buy 4 pounds of cherries, but that's really not how it works. So I need to test what side of these 2 lines I'm on as well. And, greater than 0 means to the right, which would be this way, and then greater than 0 for this line would be above this line. And then you can see all my arrows here are pointing to this region right here. So I'm going to go ahead and shade that region right there. And now what this shows me is every point in this shaded region here is a solution to this system, which means any point in this region is a number of grapes and cherries that I could bring home and meet these constraints. So if we find a point like right here, that's the point where I bring 3 pounds of grapes and 1 pound of cherries, and that fits these constraints. I could also do this point right here, which I think I said was 3 1/3 pounds of cherries and no pounds of grapes. Or I could even do this point right here, which is 1 pound of grapes and 1 pound of cherries, and you'll notice it's right on this line because I would be spending exactly $5. And so you can see any point I pick here will be a correct solution to this system. So this is a picture of all the possible solutions. And you'll notice anything outside this region is not a solution. So I cannot buy 4 pounds of grapes and 1.5 pounds of cherries because I would be spending too much money. Now, one thing I'll say when you're doing your homework, if you need to make a graph like this where there are multiple lines to draw, you should approach it the same way I did, where you draw all the lines first, and then when you get to the homework, there's a little button that's like a paint bucket, that's a fill, and you need to draw your lines first, and then the last step is fill the final region. You cannot fill 4 different regions along the way. You've got to wait until you've drawn all your lines and then fill the one final region that is your answer. If you do have any questions about how to use the graphs in the homework, please send me an email and I'll try to help you as best I can.